Okay, so now that we have the definition of the trig functions of any angle, and I showed you how it correlates to the trig functions of an acute angle and a right triangle, let's examine this definition a little more. Last time we talked about the domain possibilities, and I'm going to explore that a little more here. I also want you to notice for me that if your terminal side of the angle is in quadrant 1, then the ordered pair xy would have to have both x and y coordinates positive. Okay, and if both x and y are positive, and we know that r is always positive, this would lead us to conclude that in quadrant 1, both sine of theta and cosine of theta are positive values. And then you could survey from there. If, I circled the wrong guy there, sorry about that. Both sine of theta and cosine of theta are positive values. Now, because tangent is y over x, and cosecant's r over y, and secant's r over x, and cotang's x over y, and x is positive, y is positive, and r's positive, then all of the rest of them follow suit. So everybody's positive as a trig function value if the angle is in quadrant 1. Okay, but what about the other quadrants? Okay, well, it will really depend upon the position of the point xy, because r, we know, is positive by default from its definition. So let's look at the other quadrants. Okay, here's quadrant 2. Okay, and in quadrant 2, the x coordinate would be negative and the y coordinate would be positive. X coordinate being negative would mean that your cosine function is negative. It would also mean that cosine's reciprocal, which is secant, is negative. Y being positive would mean that sine, which is y over r, is positive, and sine's reciprocal, which is cosecant, would be positive. And then having x negative and y positive, how would that affect the other guys? Well, it would make both tangent, which is y over x, and cotangent, its reciprocal, x over y, negative, because the x and the y have unlike signs, SIGNs. Okay? I want you to follow this same reasoning for quadrants 3 and 4 to conclude who's positive and who's negative in those quadrants. Okay? So in quadrant 3, we would see that the x coordinate being negative would affect cosine and its reciprocal secant. We would see that the y coordinate being negative would affect sine and its reciprocal cosecant. And we would see that both of them being negative would make tangent and its reciprocal cotangent positive values. A negative divided by a negative is positive. Okay? And then lastly, let's go over here to quadrant 4. And x being positive would make cosine positive and secant positive for the same reasoning. Y being negative would make sine negative and its reciprocal cosecant negative. And then unlike signs would make tangent and its reciprocal cotangent be negative. Because a negative divided by a positive or a positive divided by a negative is negative. So I hope this makes sense in terms of angles that land in these quadrants. They're going to have distinct positive or negative trig function values based upon the point on the terminal side of the angle's position, Okay? Alright, we'll continue in the next video going with this explanation and expanding it.